So this video is a continuation of the series on how to get your product certified to UL, CE marking, or all of the other types of certifications you might need, whether it's NFPA or all these acronyms across the world. You're going to need your product certified at some point. And we've talked about safety warnings for labels and manuals, and we've talked about the process to get you there in the previous videos. I thought what we should do now is take a jump back and talk about all the things you will need to have taken care of to get your product through the certification process. Now, we work with hundreds and hundreds of products each year and help teams similar to yours get those products through this process. So this is the basis of, this comes from the 23 years of doing this as a consultant and a test lab, and even my previous experiences working for other companies inside as a product safety engineer or an engineer inside other companies doing this work. So now let's talk about the 10 things that you have to get your product certified. So number one, having it designed to the particular standards. This is something we run across a lot. Teams that really have it together already have the standard in hand. They know what they're designing to, and they do design reviews to get them there. But really knowing which standards you're designing to and then doing that's key to getting certified at the end of the process. It dramatically reduces how much we have to change your product in order to get it certified. And we can also help you pick standards that make it easy to get certified. The thing I did want to mention at the beginning of this video, so let me pause for a second and mention that, I'm going to dive deeper into each of these topics in the following videos. So as we go through this, know that I'm going to go deeper in the videos that come out in the following weeks. And you'll get more of that data ongoingly. Or if you really want to get this taken care of now, let's go ahead and have a conversation about it. So designing to standards is key. The next big thing that we see missed quite a bit is not having the correct overcurrent protection for an piece of electrical equipment. So not having either circuit breakers or fuses or however you want to manage overcurrent protection. If you're doing a consumer product, a lot of times you can rely on the building's overcurrent protection to manage your product. I really don't like to do that. It's acceptable, but we'll delve deeper into that in another video. But do have that overcurrent protection and have it set properly. The next thing we see a lot is incorrect wire types and sizes. So you really need to be sure that you're picking the right wire based on the standard. And sorry for that stumble saying white, but right. But also when I say white, we also have to have the right color. Does it need to be green with a yellow stripe? Does the wire need to be black or red or orange based on the particular standard? Now, a lot of the standards will allow you to use your own convention for wire colors. However, that green wire with the yellow stripe for ground, that's across all the board. You're going to have that. So please don't do your protective earth grounding in a black colored wire. Also, missing grounding parts from your system. Having most of your system grounded and then parts of it with electrical components on it not grounded is a problem. We see that on a pretty regular basis. And nowadays, all the standards are getting away from allowing you to stack grounds on one ground stud. You need to run each ground individually to a ground bus bar or an individual ground stud. And I'll go into a whole topic about grounding and how to measure it and where that comes from the standards in future videos. For larger industrial equipment, you won't see this very much on consumer equipment. Having an emergency stop button, a button where you can go and, if the machine is not doing what you want it to do, go push that button and the machine will shut down. Smaller equipment, you can rely on the power cord or the on-off switch on the back. However, for large industrial equipment, you do want that red EMO button. So if something's going south, you can push that and stop everything. Then also your whole interlock circuit as well. You want to have interlocking to prevent people from accessing hazards. So let's say you have a lid that you can open to load and unload product. That lid needs to be interlocked to prevent people from accessing whatever hazards are in there. Whether it's a laser hazard or a cutting tool or motion or whatever that's going on in there, that needs to be interlocked. And that whole interlock circuit, which we'll deal with in a future video, needs to be done in a fail-safe manner and using safety-rated components or high reliability components. We talked about warnings and warning labels last time. We see this a lot. It's kind of the last thing that gets done in the engineering process. And it's really not even something you're going to see your electrical or mechanical engineers want to take on, is all the hazard labeling. And we typically manage that for all of our customers. Just came back from a project. That's one of the action items to follow up on, is provide them all the warning labels that they need. This one probably should be with the interlocking thing, but not having guards or guarding. For bigger equipment with hazards, rotating hazards, gears, cutting devices, anything like that, we're going to have a guard, and there's a whole set of standards on guarding. Kind of the rule of thumb is if you can get your finger to the hazard, then your guarding isn't suitable. And when you're talking about very, very large pieces of equipment, we're going to use yardsticks and stuff to look for guarding there. So anyway, we'll delve deeper on that, but you got to have guarding when you need it. We talked about some of the last videos about warnings in the warnings in the manuals and documentation. You're definitely going to want to have a set of manuals, whether it ends up being a page or two that covers all the standards required, or whether it's hundreds and hundreds of pages. But the end user is going to need to know how to install this equipment, what kind of power it needs, what kind of environment it can go in. For most consumer products, they're designed to be used indoors in a dry, clean location. So we'll deal with all of that and the whole manual issue in the future. But you got to have your manuals, because at the end of the listing process, we're going to have to look at those manuals and say whether they have the required information or not. Here's one that we get a lot for process equipment that goes into California, the West Coast, or any other area where there is seismic activity, potential earthquakes. You have to have restraints to keep your equipment from toppling over. And for consumer products people as well. I mean, if you're building a bookcase or a dresser drawer or anything like that, you must have some way to attach your equipment or product to the building, so if there's an earthquake, it doesn't tip over. And there's a neat aside. I was working for a large Japanese company doing a seismic presentation, and I'm in the building and there's an earthquake, and everybody got to laugh at me because I was like shocked that here we are doing a presentation on seismic restraints, and there's actually an earthquake during the presentation. That was really funny. It was quite the adventure. The next big thing is like the whole ergonomics of it. If it's industrial equipment and people are interacting with the equipment a lot, there's a bunch of standards around what the ergonomics of the equipment must be. And even down to how you design and label the controls and control systems and graphical interfaces. Not having that managed, not having all of the capability for people to interact with your equipment and understand it easily and do it day in and day out without getting an injury, an ergonomic injury, is critical. The next big thing we see a lot, and this probably will be my next video, is your bill of materials and all your critical components. And each of those components having their own listing, being CE marked, being UL listed, or one of the other recognized test labs, having those marks on there already. So when you incorporate those parts into your equipment, we're not having to redo an evaluation on a secondary component. So, for example, a big one we see is transformers. If you have a transformer built by a UL recognized transformer manufacturer, they can go ahead and UL mark it. Or if you're buying high volume parts, you want to find a UL recognized transformer to use in your equipment. And that applies to everything in your power, in your interlocking, your controls, everything. You want all those parts to be UL listed and CE marked. Even like circuit breakers and relays and all those other parts. And as you build your bill of materials out, you want to capture that UL listing data and those cut sheets as you do your part selection. Just save each of those to a file, and if you have the time, and I really recommend this, when you're selecting the part, go ahead and on the PDF mark down what part number you selected and where it is, and you can even highlight what you selected. That way you won't come back and look at it and know, okay, this is why I picked this part. But also when I look at it, or let's say you move up in the company and somebody else has to do that job or pick a different component, it's super easy and you did it while you were thinking about it. I get to mark up PDFs a lot for clients afterwards, and if you do it up on the front side, man, it really is a thorough and complete job, and it really, it's very helpful. Those are really kind of the big things we see. Smaller things we see that happen on occasion are, not really dealing with the whole entire design package, not having really good drawing set, not having revision control in your drawings, manuals, and bombs, and then not having all of that stuff kind of stored in one archive. If you store it in one archive somewhere, let's say a computer gets damaged or somebody leaves the company, or, let's not even talk about this, but we did have a client that a laptop was stolen out of a vehicle, and that engineering guy had most of the design data on that laptop. So keeping all that design data in an archive will help you out at the end of the game. Let's see, to sum this up, if you can get all these things in place as you're going through, great. You'll have a much more robust package, and you'll be more likely to get through certification more quickly. Without these items, you're going to need help. You're going to need more and more help to get this done. So let me know how we can help out, and then in the future videos, I'm going to deal with each of these topics in depth. I'm going to deal with the bill of materials first because that's so important, and then we'll dive into part selection and overcurrent protection and everything else as we go along. Have a great day. Hope to see you soon.